At first it's only a ragged line of flames, creeping through the thin ground cover of moss and lichen at less than 1 meter per minute. It takes a good 5 minutes for the flames to reach the first clump of black spruce. Dead lower branches and fallen twigs catch fire. In a few seconds they are burning fiercely. Suddenly, a finger of fire races up the trunk of one of the trees. Topmost branches flare skywards. On the ground, the initial flare-up has settled down into a steady burn. At the front of the fire, the temperature is rising by the second. What moisture there is in the ground and the trees themselves is evaporating swiftly, not only at the base of the clump, but in upper branches and in the ground cover beyond. And then... But look at what's happening on the ground. Remember those tiny flames which crept into the clump? Look at them now. Northern Affairs Program firefighters know all too well the terrifying speed with which fire spreads through black spruce, the Northwest Territory's most common trees. Black spruce is one of the most volatile fuels on which fire can feed. But they, and scientists of the Canadian Forestry Service, could hardly believe their own eyes as they watched these flames roar through ground cover no more than 2 inches deep. That was what Porter Lake was all about. Porter Lake started out as a plan for experimental burns and field training for Northern Affairs firefighters to be held in the summer of 1982. The lake, 280 kilometers northeast of Fort Smith and 340 kilometers southeast of Yellowknife, offered many advantages as a training site. It was remote. Snowdrift, the nearest settlement, was 160 kilometers northwest. There was no commercial timber in the area, it was not good trapping land, and there was an old Forestry Service camp on the lake. Burning is a firefighter's tool. The Porter Lake experimental burning would be done to give Dene seasonal firefighters from Snowdrift practical experience. A long point at the east end of the lake would provide a safe area. And if one of the fires which would be set did escape, there'd be no hazard to communities or trapping areas. In 1981, Northern Affairs had made $150,000 available to the territorial government's wildlife service to carry out basic research on the effects of forest fire in caribou feeding ranges. Information on many of the old burns around Porter Lake was on record. That made the lake an ideal area for studying not only the immediate effects of fire on moss and lichens, but also the rate at which they grow back after fires. Safety was the prime consideration in all the advanced planning. Fire is no toy to be played with. It kills people as well as trees and wildlife. No one knew that better than the people who'd be in charge at Porter Lake, all of them experienced firefighters. There's no road into Porter Lake. Everything must come in by air and move by air once it's on location. A helicopter was laid on to handle traffic between the base camp and fly camp and provide firefighting support if necessary. All burning would be done in small sections. Most burns would cover areas 40 meters wide by 60 meters long. Others would be smaller. Though Porter Lake is rarely visited, even by hunters, Rick Laneville and his crew were concerned about preserving the natural beauty of the land too. So they decided to leave an unburned strip about 100 meters deep at either end of the burned-off sections. That would conceal the burn from travelers on the water. That, as it turned out, was an expensive bit of landscaping. For the team in charge was a new, fully automated weather station, which was being tested as part of the program. Before any test burning began, the CFS scientists carefully examined each site. A second anemometer, closer to the ground than the one at the weather station, was used to double-check wind speed readings. Soil samples were shipped back to Yellowknife for detailed lab examination. All eyes are on Maud Cassaway now. He's one of the Snowdrift crew, and he starts the burn. There are two types of burns. Point ignition fires are started with an ordinary kitchen match. They simulate what can happen when a lightning bolt hits. A line ignition approximates what happens on a going fire. The end result is the same. Numbered metal discs scattered about the perimeter of the fire at 5-minute intervals mark the speed of its advance. Distances from the point of ignition can be measured after the burned-over area has been hosed down. On the sidelines, the suppression crews quickly douse flames which have spread outside the test strip. The day was hot and windy. The schedule called for a burn along a wider front this time, 100 meters instead of the usual 40, but of the same 60-meter length as most of the others. Forest fires create their own windstorms, and it was already windy. Burning debris was sucked high into the air and blown 300 meters across the water to the south shore of Porter Lake. In the space of 5 minutes, test burn number 6 had become fire CR6. That full-fledged forest fire would burn 1,300 hectares before it was halted. Porter Lake was a series of test burns in one rather unique type of forested area of the Northwest Territories. The more we know about wildfires, the more effectively we can fight them and work to prevent them. And in experiments like those carried out at Porter Lake, that's just what we're doing, learning to fight fire with fire.